All right, welcome everybody. My name is Sean Kinney with RCR Tech, and we have a discussion today titled Scaling AIOps from Insight to Action. Some quick housekeeping notes before we start. We are recording the discussion today, and we will make that available on demand if you'd like to revisit the content. And we've reserved time towards the end of the hour to take questions from the audience, so please submit those throughout. We'll get to as many as possible, and if you'd like them directed to a particular panelist, just let me know. And I'd also like to put on your radar a report that we've got coming out that'll go a little deeper into this topic that's due on May 5th. So please keep an eye out for that. To give you a little bit of context, the telecom industry's working very rapidly to move AI-enabled projects from pilot phase experimentation into scaled production. That covers a range of use cases and types of AI. In the generative AI side, you see a lot of things around customer care, document summarization, and engineering support. And then you've got a lot of attention on agentic AI that can do things like root cause analysis, self-healing, field operations optimization, and reducing network energy consumption. So whatever the particular focus area, the through line, the goal is to reduce cost, increase operational efficiency, and optimize the performance of your network. I referenced this move from pilot to scaled production. This is a tricky step for mobile network operators, but it's also a tricky step for any large enterprise that's working to bring AI into their operations. There are a number of technical challenges around data readiness, data governance, integration with legacy IT systems, and drawing a straight line from your AI spend to ROI. Experienced a power outage here in Arkansas. Apologies for that. As I left off there, I was discussing the organizational challenges around integrating an AIOps methodology that includes redesigning workflows, defining operational domains and subdomains, surfacing interdependency, and fostering an environment where engineering and other teams learn to trust AI-driven outcomes. So the goal today is to get perspective from a range of experts who can share what our industry is getting right, where we need to focus our efforts, and what's actually working in the real world. The direction of travel here is clear. AI needs to sit at the center of business, and operationalizing it at scale will influence success in the coming years. To talk about it, we've got a great panel. I'd like to introduce Fatih Nar, who's the Distinguished Chief Architect with the CTO's Office for Red Hat, Rafael Ballesteros, who's the Head of Business and Technology at Tupl, and Ahmed Abdelaziz, VP of Automation and Transformation with Rakuten Symphony. So with that, I would like to turn it over to Fatih, who is going to dealing with technical difficulties here. But Fatih, I'd turn it over to you now, please.
So first of all, Sean, go Hogs. So I always go Arkansas for Thanksgiving and Christmas. Good morning, good afternoon, wherever you are. Thanks for joining. My name is Fatih Nar. I'm a Distinguished Chief Architect in the Red Hat Field CTO office, and I have spent significant part of my career mainly in the space where the IT infrastructure meets with the data-driven insights and intelligence. I was previously at Google, RCR Wireless as Distinguished Engineer, and a long time back, beautiful Ericsson as a Systems Engineer and Solutions Architect. So I would like to start honest and modest and to the point. The debate for does AI matter for IT and telco? This debate is over, in my humble view. Every partner, every customer, every operator I talk to, whether they run a tier one national network or a regional mobile operation, they passed the phase of the should we use AI ML question. Now we are in the phase of how do we scale our AI ML solutions effectively and efficiently wherever we need it to. That's the question that we are tackling right now. That's exactly what we will talk about today as well. Not theory, no fluff whatsoever. Definitely not another vibe-coded demo, which is fake things. And we will walk through a kind of a practical and step-by-step journey from data silos to a living, self-healing, hopefully a more pragmatic approach for lowering the MTTR networks. So the problem, the uncomfortable truth is the average telecom operator sits on an enormous volume, variety, and velocity of data. Volume as in the sense of big data, archival data, Variety as in the sense of having multi-tenant operational background, different data types. Velocity is the speed of the data it has been generated and still going on like the light speed data generation for both the radio side as well as core, as well as OSS, BSS, by means of transactions, CRM records, and so on and so forth. So data is out there somewhere in the wild if you can find and use productively. So that's the main challenge. So another challenge, let's say you found the data, but it's locked down inside the silos, owned by different teams. So it's stored in different formats and protected by different access policies and governance models. So what happens? A team builds a POC, looks good in the demo, but it uses a clean data set usually. Somebody has hand created or even fake it with the synthetic data generation for the sake of showing the success, beautiful dashboard. And then when the things become a real going into production, projects usually halt because of the data pipeline wasn't real, because the features that has been used weren't there to start with. So nobody applied the domain expertise where needed to apply to make the model more trustworthy in a live network environment. So we call this as a fake demo trap, pretty much. It's the number one reasons nowadays the AI projects in the telecom fail to deliver ROI is fake demo. Non-existent features, non-real data pipelines, hard to integrate with the multi-tenant or multi-vendor ecosystem, and so on and so forth. So how do we progress from here? So maybe we go step by steps, as the new kids on the AI blog says. So the data. So you got to introduce stakeholdership to govern your data needs. Maybe you may do additional data rigs, like in the oil rigs, right? You need to capture the data that you needed to, but it doesn't exist yesterday. So bundle those data points with the open telemetry to export easily for harvesting metrics, events, logs, and traces across the full stack, from network, from OS, from platform, from application, and then apply zero trust access controls right at the start with PII. Mask those in critical data features at the source, not after the fact. If you do after the fact, you will have a lot of data leakage, subject to regulations, penalties, so on and so forth. And then let's say you did the homework for data preparation, data pipelines, then you have to apply domain expertise. This is some of the project goes really wrong because we learn based on the I would say experience that we kind of inherited from CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. I know it's a lot of words, but this has been the gold standard over 20 years for data mining and data engineering processes. So the key concepts under CRISP is understand the business problem, explore the data, engineer the features, build the models, validate those models against your ecosystem reality and field and traffic reality, and deploy continuous monitoring for drift analysis, accuracy check, maybe feed back the new fresh data as in the velocity of the new data, and update those models continuously and deliver with the MLOps methodology. So the important hint in this step is data preparation consumes up to 80% of the project. So people will say, oh, this was old story. This was in the classic ML AI. Gen AI covers that. No, my beautiful friends, GPT. People think this is generative pre-trained algorithm, but it is a general purpose technology. It's not tuned in, addressing your special needs in the telecom IT for predictive maintenance and issue classification. For those, you have to use your own data to either fine-tune or complement those models. Now we're going to touch another approach coming in this step that I'm going to talk into a little bit. All right. So the long story short, do not use generative AI where classic machine learning fits in. For example, as I was hinting, with the structured telco data for fault prediction, anomaly detection, forecasting, and so on and so forth, you can use decision trees, logistic regression, linear regression. Those, my friend, in our humble experience in the field, beats the general purpose tech LLMs every time with less resource needs. Gen AI, though, I'm not saying it's totally bad. Gen AI shines for content generation, conversational interfaces, code assistance. Even you can take it to further. Hey, I detect this anomaly with the pattern recognition that I use my normal archival private enterprise data. And then I can find I can use that generative AI to possible remediation paths. So what we are doing is matching a technique to a problem rather than solve it via like a off-the-shelf AI model. Okay, so as we are in 2026, right? We're going 2027. We are evolving from central AI solutions into a distributed AI solutions, as in the sense of AI grid. If you haven't heard the term AI grid, I promise you, guarantee you're gonna hear it, because we are evolving from central intelligence to a distributed intelligence. Think AI as a service delivery as a distributed grid with 4 tiers, okay? Say your engine, the big engine, sits in the core data center. And your gearbox, it could be the protocols that you're using those engines with, say, MCP, so on and so forth. And you can see this as a transmission fluid. So carrying this intelligence towards the edge, where the rubber meets the road with the agentic application, the agentic approach for fixing the problems or delivering a duty for you. So difference between generative AI LLM model versus agentic solutions is agentic solutions does the job for you. It doesn't only answers a question and answer. It does the job for you. This is where the agentic orchestration comes and becomes very important. So at the core center, as I was hinting, you train fine-tune large models, say 100 billion parameters and above, with full precision on multi-GPU clusters. This is strategic reasoning layer, okay? So at the regional layer, though, when you go towards the edge, at the regional layer, you distill those models down to 40 to 90 billion parameters. Now we are kind of sliming the model to fit into where we can accommodate them. We pair them with the retrieval augmented generation for local context. This is your digital twin layer, city level decision making at 20 to 50 millisecond happens. At the edge, at the RAN side, you quantize those models down to, say, 4 bits. Small, purpose-built fast models, delivering inference from 5 milliseconds to 20 milliseconds. You can leverage for how can I configure for better beamforming, because you detected that there is a kind of a radio access issue by means of pattern recognition or anomaly detection. And now this small model telling you how to reconfigure this radio station for better optimization, better energy management, and so on and so forth. You can leverage X apps backed with these small models, say using MCP as a protocol. At the far edge, now we are almost reaching to a point if you haven't seen, there are a lot of local phone hosted models. One of them is, I think one of the lead one is from Google, to run even for iPhone and Android, is they're running these AI models on the devices, sub-billion parameter models for neural processing units, say 1 to 50 millisecond inference on device intelligence. So the long story short, train at core, distill to region, quantize for edge, and hand off the device. This is where different use cases based on different expectations for latency becomes a reality, okay? So how do we govern? So you can place those models on the grid as you're doing, but this is half of the job. You need guardrails to run continuously for drift monitoring, latency control, hallucination control. And I know I keep repeating myself, but right sizing is the critical lessons learned in here. Do not use a gigantic 100 billion parameter model if you can address the same use and needs, say, with the 10 billion parameters, 1/10 of the size, 1/10 of the resource needs, 1/10 of the energy, that has been sucked out of the grid. So all matters by means of balance. Okay, so Fatih, you're talking too much. Tell us some concrete examples that you had done. One of the I think important projects we have delivered, most of our projects, by the way, I'm gonna mention the link where you can find them, is 5G fault prediction end to end. So we started with the collecting radio access network KPIs, signal strength, packet drops, signal quality, channel quality, and so on and so forth. And we kind of harvested that data using OpenTelemetry exporters, and some with the eBPF data harvesting out of the Linux kernel. And we enriched that data with archival weather data and external weather predictions using AccuWeather API patterns, and social graphs for events, highway density indicators, to create a traffic forecasting planning powered by AI inside. So people the organizations of the network operations team can send right people to right place or upgrade their hardware wherever they need it to, rather than just, oh, let me upgrade in being a cautious way. All right. So we have leveraged hybrid approach. We use both classic machine learning with XGBoost for tabular data and also the generative AI small Quen models and over 60 months of production equivalent historical data powered by the OpenShift AI and GPU acceleration. So we use OpenShift AI on the core data center for the bigger GPU cluster for bigger model training, bigger insights generation, and distributed with the LLMD for running inference in distributed fashion in the regions at the edge with the smaller GPU footprints for delivering low latency prediction for radio access networks. Okay, so the result is mainly we addressed almost up to 23% fewer outages in that particular service provider or for the radio access network. And we also did the post-mortem analysis, which we published on the Enterprise AI article series. So this is only one of the 20 use cases we have built as telco AI experiments. And the data sets are on the Hugging Face, publicly accessible. The Jupyter notebooks, the models, the approaches, data pipelines, MLOps pipelines, all on the GitHub. And for you to take a look at, and we can collaborate with you additional use cases as well. Okay, so where do we go from here, right? Where do we go? Today in 5G and 4G, AI is an overlay, add-on. It's an external service bolted to the network for a centralized, high latency request response. It works, but it's very limited. So the vision with the 6G is where industry is heading is being AI native. AI is not an add-on, but an intrinsic property of the network. So this is where it becomes AI inside concept rather than AI, oh, we are using AI thing through an API. So we are moving from connectivity providers to intelligence service providers where the radio spectrum used much efficiently, energy consumes in a better way, and the coverage goes up and down based on real traffic demand. So everything we described and enclosed here is open source, as being Red Hat being the open source company. We have leveraged OpenShift AI, open weight models, open protocols, such as MCP, A2A, and ACP. There's no vendor locking. All our experiments publicly available, as I was hinting. And the network of the future doesn't just connect, it will think, it will act on behalf of things. This is where agentic AI becomes a reality. And we are building the platform to make that happen. And I'd like to thank you for your listening. Thank you for your time. Please do not hesitate to reach out on LinkedIn and connect for additional queries and your challenges. Glad to help you. Thank you.
Hey, thank you so much for that talk, Fadi. That was really interesting, and I think you raised a lot of points that we'll explore more in the Q&A. So thank you very much. Now I'd like to introduce Raphael, and my colleague Hannah is going to bring your slides up. So
Thanks,
over
Sean. So maybe while the slides come up, just a brief intro about myself. Been in the software industry all my life, starting in small companies like Microsoft or Samsung, and I started in telco at Tupl, basically doing automation. We've been doing automation at the telco scale for the last 11 years. This is where I built all my knowledge of telco before it was only software, So I'm glad that you invited me to come here, and we'll talk about a little bit about what are the challenges that we've seen in this long journey that we've had on the telco world, right? So basically, the reality of network operations today, if we move to the next slide, is this has been mentioned before by Fatih. I think he's totally right that a lot of the time is spent on the loads of data that you have in the telco world, right? You have many data sources, different vendors, not just OSS, BSS, call records, customer information, and that you need to. Sometimes what happens in these environments is that you end up having what I traditionally have called a data swamp, right? It's not organized well. You need to process it. You need to distill it, right? You also have, alarm data, things like that, that are basically making it hard to organize and distill that into useful insights, right? Then what you have in the telco world is a pressure, or two types of pressure. One is uptime, right? You need to make sure that the network is up, and networks are, or your wireless operators are uptime driven, right? And you basically need to fix issues as soon as possible and keep the network up, right? So repair speed is the ultimate measure of this operational success, right? And then you have what we've seen in the industry, in the different operators that we've come in, is a passion for dashboards, right? There's a lot of insights that are displayed in beautiful dashboards, but there's less focus on closed loop automation. Basically, what it would take to go from an insight to a root cause to a deployed action, right? So in most cases, we've seen that AI, all types of AI mostly sticks in the analytics side, right? And not on the operation, right? So if we move to the next slide, so why are they failing, these automation efforts, when you get to the operators? And we see a lot of fragmentation in the efforts, right? We see many small automation efforts that are basically scripts that in various stages of deployment. Some are in VMs, some are in small clusters, some sit on somebody's computer, right? And they get run on schedules. And it's a single developer world, right? Where you see these, if the developer goes away, nobody knows how to fix this or how to run the system, right? The other problem that we see is in standards, right? I think this is one of the key things that operators should focus on, right? So you need to make sure that the AIOps are not seen as a basic harness to run a variety of use cases, but you set up your standards as far as, how to process the input, what is the output, how do you do the logging, how do you manage security, how can you connect to these systems, through APIs, through MCPs, agent to agent, so basically you need to set your standards as an operator, to how your vendors or your AIOps delivery operators are going to serve that type of technology, right? We have brittle systems, right? We have very obscure monitoring. Everything is in code, hard to understand what the system is doing or how it's failing. And then the final problem that we see is AI use, and I think we've mentioned this before, or is you mentioned before by Fatih, AI without outcomes, right? So we do a lot of investments in like I said, determining a good dashboard, I don't know, basically trying to find how if your customers are feeling happy or not. But what does that give you? Does it give you any return of investment? How do you measure, if your investments in AIOps and automation are bringing you the savings that justify that investment, right? So most of the time we see that, these AI efforts don't reach the operations, right? So on the next slide, how can we shift from that? What can we do to improve these type of AIOps or automation, right? So we feel that there needs to be a core platform, right? So you need to have some easy to deploy, easy to scale, configurable, and also built for telecom, because let's face it, telecom has very, is very idiosyncratic. It has many things that are, specific to telco. The wireless network, the data that comes in, multi-vendors environments that have grown over time, so you have different pieces of data that you need to put together, and you need to have the knowledge of the wireless world as well, right? And these systems need to be operating 24/7, right? So you need to standardize this ecosystem. You need to bring that unification of vendors, bring those data formats together, and have a workflow under one roof, right? And I think to the point that if you're discussing automation with a wireless operator and with network engineers, they're always afraid of the decisions that a system might take, right? So it's good to have a good combination of deterministic rules, traditional ML, right? And also use your LLMs, for the right purpose, which we definitely think is for deep investigation and changing your systems, right? So we'll see that as we move forward in the presentation. But in general, your AIOps should be adaptive, right? You should react to changes in the network and be able to change your systems, fast, right? And these systems should be able to adapt. So on the next slide, what kind of platform to reach this goal, right? And you need to be reliable, proven, predictable, and trusted, right? So you need to, as we mentioned, use deterministic rules for known, repeatable scenarios where you will have zero ambiguity and people will be able to trace how decisions were made. You need to have traditional ML models for stable decisions, also with measurable confidence. This is also about being able to treat problems that are hard to model with just deterministic rules. And you also should have a platform that standardizes your entire automation ecosystem, right? So on the other side, you should have a adaptive intelligence. You should have a system that reacts to anomalies, suggests changes, and keeps learning as new cases come in, right? So your AIOps should not just execute, it should evolve alongside your network, So how can we enable this, and basically as your system continues to improve, it can get smarter, right? It can detect anomalies, it can detect new patterns, it can suggest new resolutions, and your coverage expands organically. This is where SMEs enter in the picture, right? Where doing this deep investigation, if you're able to, sum or add the knowledge of the detection of an anomaly by the system with the deep investigation of a subject matter expert, you can bring this together and deploy fast in a automation environment. This is how your time to market will improve, and you also reduce human dependency in just facing repetitive issues, right? By the way, this is happening in the industry right now. I mean, we're seeing that automation is not just a nice to have, but a must have in environments where knowledge is scarce right now, and operators are reducing their workforce dramatically, right? You can have cross-domain correlation. So in a way, the way we built our systems, throughout our experience in multiple operators, is by being able to connect that network knowledge with what's really happening with the customer, right? So if you're able to mix this data and you're able to use these systems appropriately, you can come to the holy grail of Well, if there's an issue detected in a site, for example, can you report that back to the customer in, near real time, in seconds, right? And that's that's the ultimate goal that you need to thrive or strive towards, right? You need to be able to connect your network systems to communicate with your customers, whether through customer care or directly, right? Because that is the ultimate goal. The ultimate goal is to have faster mean time to resolve and higher uptime for your systems, right? So if you're able to have, your reactive systems are able to evolve fast and turn those into proactive fixes for the network, you can reduce and measurably reduce your outages, right? So maybe on the last slide, just wanted to bring some of the experience that we've done, with multiple operators, T-Mobile, Deutsche Telekom, Telefonica, we've basically been able to deploy our automation systems in the last 10 years, and we've evolved our systems to be able to deploy fast use cases, that are customer focused, and these are both events that help or technologies that help on the network operations, on optimization engineering, network operations, and also connecting the dots between, the wireless world and the care world. How can you report, give information to customer care fast, that, you're able to, when their problem is going to be solved, and what is happening, why they have dropped calls, why their internet is slow, right? So having that direct communication from engineering to customer care, I think is one of our top assets as a company, right? And we're driving our systems to be level 4 autonomous networks, right? So we be able to reduce the time it takes to improve the AIOps, improve the automation, improve the root cause analysis by using this latest technology, the LLM, to be able to close that gap into how fast can you improve your systems, right? So that's it. I think probably open it up to our next speaker, and then we'll go on to questions. Thanks, everyone.
Hey, thank you very much for the presentation, Rafael. And now, Ahmed, I'd invite you to join us on camera, please. All right.
Hello.
Thank you very much. How are you today?
I'm good. How are you doing?
Excellent. So I appreciate you joining. You've got some really relevant experience, and I've got some questions for you, Ahmed. But before we get into that, I was hoping you could just share with our audience a little bit of overview of your current position with Rakuten Symphony and your former role within Rakuten Mobile.
Yeah, so I used to run operations and automation in Rakuten Mobile for around 3-4 years, around the launch of the network of Rakuten Mobile in Japan, which was the first Open RAN cloud native operator in the world. So after that, I moved around 3-4 years ago to Rakuten Symphony, where I'm still working closely with Rakuten Mobile and our other customers for helping them into their transformation journey and automation journey toward AIOps and toward, autonomous networks.
All right, so lots of learning by doing and now supporting your customers through Symphony. But I guess the big question here is how much of the successful transition to an AIOps methodology is about technology versus how much of it is about workflow redesign and really reorienting how your staff works?
I think mostly technology, it's a major part, but I wouldn't say it will take the majority of the stake. So I would say I'll put it at 30-70, 30% in technology, 70% is organization and a workflow and operational model. Because the technology that have been used for the AI, it's available everywhere, and we could see the open community and the GitHub community, and Fatih was sharing like people who develop the AI and develop the technology are not mostly hiding it, but they're making it available for the good use of others. But the hardest part is the silo that happens within the organization. And a lot of it is because the network, if you look at it, it's a lot of domains working, interacting together, and a lot of bigger organizations interacting together. So for me, I would say that the organizational aspect of it and the workflow is where the AI ops work. Like I would say, if you still run AI like today and you still run it in the same method you're running it, you're gonna end up with a human still interpreting and a human still, like becoming the escalation. Then you're mostly using AI as an advisory. But when it innovate and it evolve the operation model, then it becomes more like as a true AI ops.
Excellent. And you referenced there this idea of breaking down data silos and understanding different network domains and subdomains as you redesign your workflows. Can you maybe elaborate a little bit on what that process actually looks like for an operator in terms of defining functional parts of a particular domain, the people that work within the domain, the data that resides there, and then understanding the interdependencies with every other part of the network? Just what's the real world process of doing that take?
So the process starts even a step before that. So when you talk about coming to a use case and defining what is your use case, because this is where you start. We cannot change the entire domains and or revamp the entire network in the same time. So first you start by a use case, understand where is your pain point and where you want to start to go onto this journey of autonomous network. Let's say, for example, you are a company that is having a large energy footprint and you want to reduce that, and you're trying to decide to concisely make the AI ops part of your energy efficiency journey. Then what you do is you look at all the data pipeline that you're involved into, let's say this energy efficiency use case. And then you look at what domains and what subdomains is it touching. And then you start working as a forum into making to understand what are the decision points, the execution points, the guardrails, and which domains does it touch. Because most of the use cases that are now being developed will have to get a larger utilitarian value. It will needs to be cross domain, because we know that, like, sometimes you can run a RAN experiment or you can run a core experiment as a standalone, but when you are coordinating these functionalities, you need to do it in a way and a framework that can be repeatable. Because if every use case you build a new framework for collaboration and a framework for your models for your repository, you're not going to end up on the long term with the larger results. It will be exactly like if you go every time into your Jupyter notebook and write a hello world program. So it will be less kind of like able to consolidate it on the long term.
You referenced something interesting there that I'd like to circle back to. The distinction between true AI ops and using co-pilots. I think a lot of started with co-pilots that made a lot of sense based on the tools that were available. We saw those pop up in customer service support primarily, but then into engineering productivity support. But what is the distinction between relying on a co-pilot to boost productivity versus fully embracing AI ops and decision making?
I think Copilot is a very good start point because it enables you to go into this journey. Copilot is in some manner, I would consider it as more like as boosting efficiency. So it is human efficiency rather than focusing on the network efficiency and focusing on the operational transformation of AI ops. So when you go with Copilot, you're still having the human in the loop. You're just allowing them to do their work with a higher efficiency, and you allow them to gain the trust of the AI, or make the AI gain the trust from the human. Because first of all, you're assessing the results, you're calling the shots, the responsibility still lies with a human being. So in that case, it's a good foundational layer where you're able to like assess the models, assess the results, assess the feedbacks, assess the hallucination that happens from the models or from the AI, and be able to assess the impact that it has on the human processes of work. But this is not the closed loop kind of autonomous way of handling. The next logical step is to actually make the model be able to do the decision part, be able to do the analysis part, and be able to do the post analysis and post decision, post mortem analysis if something goes wrong. We have seen it, like life is very kind of like predictable in a certain fashion that there are a few fundamental that never breaks. And you've seen it even today at the beginning of the session with you, like, outages are inevitable. But actually chaos is optional. So, like with AI ops, you control that layer of what happens with the chaos that happens post an outage. We are always going to have a network outages, but when you have a co-pilot, it will tell you, yes, there's an outage and this is the rule, but there still needs a human to be there. He needs to run the decision. But once you go to that autonomous framework, you kind of control the guardrails or the envelope of other chaos.
Yeah, and this ultimately boils down to trust, right? An organization developing enough trust in a particular AI-enabled solution to go from human in the loop to closed loop. You wrote an interesting blog post that almost got into how do you measure an engineer's trust in an AI solution, but just more generally, how does Rakuten Mobile think about making that move, and how do you see trust being something that is gained to the point where you can really go from, we heard an earlier reference to level 4 autonomy, which I believe Rakuten Mobile has a validated with energy efficiency in the RAN, for instance. What's the dividing line there? When do you decide it's the time is right to fully remove that human in the loop?
There is no specific point where people measure to it, but it comes with the criticality of the activity. I think it's same in all domains. Like if I'm a doctor, I can use a diagnosis of AI, but I would not make an open heart surgery with AI like with the same amount of trust. The same with networks. Like for us, the use cases that was we saw a lot of value and a less network risk, a less risk for our subscribers were the one where the trust threshold was a bit lower than the higher network efficiency or the higher network like network localization and outage prediction and outage kind of like prevention. These are harder because the more your network elements and the more your blast radius of the domain or of the activity increases, this defines and dictates your level. And you have to think of it as a hive mind because people still looks at AI and even in AI ops as agents or even AI ops as, like as a back end engine that is running an activity on the network or RIC and RApps, for example, is a big example in that I ran. There is no yet the tying like hive brain, which correlate all of these because all domains and all network teams are now following the passion and trying to go and automate their job to make the network work more in an efficient way. But you need to have this coordinator or orchestrator. In our case, it's our orchestrator, where you're able to Rakuten Mobile use that orchestrator to make sure that all the automation part that is running in the network, all these agents, the activities are within a specific guardrail and they're not contradicting. I don't want the RAN team to be, like increasing this throughput by running like a change that is contradicting with the core team or a third end team that has a different network intent that is contradicting. This is where conflict management and this kind of framework becomes very, very important. So my threshold, I would say, is that like for us, like for example, anything that achieve 90% of human approvals during a run period of 3 months, this is in general considered as an acceptable approval, but it increases a bit more based on the use cases. Like we're now even moving that like threshold as we find more cases where the AI, for example, does not operate as the highest efficiency. So if you give it a 98 and you find that at 98 your cost of decision is becoming even higher, then you change that threshold even higher as you go. So there is not a specific threshold, but it moves with time and with experience.
Excellent. And last question here, Ahmed, before we move into the group Q&A, but just what practical advice would you give our audience as they try to go from implementing AI as a point solution that serves a narrow use case to following a longer term holistic strategy that really builds out AI as something that joins across their network domains?
So I would say the organizational part of it, of the interaction between organizations when it comes to AI, especially when it happens in a larger organization, having this task force that somehow becomes like an AI review board when it comes to the deployment, this is very key so that you can unify the way you integrate AI. I understand that every team is gonna still go and do the narrow use cases now because this is where the pain point is. And this is very, very kind of like promoted. And I promote such thing that you put your hands on, deliver use cases that is solving your pain, even whether that automation, copilot, as long as you're solving a pain, you're rallying the team behind the idea of the AI. But after you set up that forum, what the idea is that you have the building models or the building parts that allow you to build the system that operate the AI. Because once you start building, like it's in every developer know that when you've written 1,000 lines of code in one notebook, it becomes very harder to change your code. But when you start to modularize and break down into blocks, it is easier when you find that something not working in the pipeline that you are able to come back and fix it. So I think having an AI system or platform where you can track your data models, you track your data pipelines, you track your explainability of the models is important. And then after that, in the decision point and post decision point, having an LCM or like an orchestrator function that can orchestrate the decisions in the network. The network is a huge part and so many thousand parameters, so many thousand domains, vendors, all working in silos. Breaking that and having somewhere where it becomes an authority of execution and authority of decision becomes very important so that you can expand more.
Excellent. Thank you very much, Ahmed. We appreciate your point of view. And now, Fatih and Raphael, I'd invite you to join us back and we'll get into group discussion here. Reminder to the audience, there's time to submit questions if you'd like. I would like to build on this point around establishing, growing, and even measuring trust within an engineering organization in the AI tooling that they're adopting. Fatih, as you scan the work you're doing with your customers, any kind of commonalities in how they think about trust as an organization and developing it over time?
So first of all, you cannot trust granted for every use case, every occasion, for any given model. Just understand that there's no trust. There is guardrails to protect yourselves out of what's coming out of that AI engine. So obviously, I'm not telling you you're gonna die and you're gonna be painful. I'm saying do your homework, do your benchmarking. Say I have these open weight models from, as I was hinting, from 1 billion to 10 billion, 10 billion to 100 billion, 100 billion and above, based on your use case, your expectation, and then do benchmarking, different use cases, different questions. Do like the model. Frontier Labs do their benchmarking, right? The humanities last exam. So we built the telco's last exam for radio access network, 5G core, CRM, and transport network. We benchmark together with the NAPs individual models that is really looking promising based on their sizes and their quantization levels. So long story short, do homeworking, do the benchmarking for your use case. Where are you gonna run that model? With whom, with what capacity resources you have available, and then build the guardrails around it. Maybe you will do model chaining, right? Maybe you will have a RLHF to correct the answer. So you have to build your framework with the key assumption that AI engine gonna fail you. You build your guardrails around it for your deployment model, for your use case, for your resources available for you to consume.
Raphael, what's your perspective there? I know that you've been involved in long-term engagements with, you referenced T-Mobile US and DT in Europe. So how does this look like from the operator side, this idea of establishing and growing trust?
Yeah, I think my thinking here is that trust is not given, it's earned, right? So in your system, basically you have to build that trust, right? I think the way we've approached it in the past is through open loop, closed loop, right? Your automation, your AIOps needs to have this concept of closed loop and open loop, where during open loop, you're reviewing the outcomes, right? But not making any changes, and then you can transition, given the right level of trust, to closed loop, right? And yeah, I think that's obviously you need to have systems like anomaly detection, when you have kind of model drift or or your deterministic system is going haywire because there's a new type of input that's coming in, right? But I think in general, the open loop, closed loop is what I would suggest, right?
Right. And then another question here, and this occurred to me during Mobile World Congress. There was an agentic AI summit, and there was a lot of discussion over the course of that program around the distinction between data and context, which I think is really important when your goal is to make a particular network process autonomous. It needs to understand the desired outcome, which will be business specific and will be specific to a point in time, even. So, Ahmed, maybe we can start with you. What does it mean to have your data ready for AI, and what does it mean to define the context that the AI will operate within?
So I think the context is like, in my opinion, is in three areas. The first area is the intent. That intent layer is, what do you seek to achieve? And that intent can be in a human language. And I think in TM Form, even in level 4, they have a defined criteria of how you can achieve the level 4. And part of it is the intent, an intent translation part. So I think that is a large part of the context. But within that intent, when you look at it in general, it also includes, like guardrails part, which is like the envelope where you're running within that intent. So it allows you to, like, I think as Fatih mentioned, like, we know AI models are like human. They're gonna make mistakes, and we have to assume they're gonna make mistakes. Like, same with any kind of system. So you need to put a guardrails or failure limiting guardrails, which allow you that whenever, if something goes wrong, you're still within a boundary of decision where you don't impact the network very bad. Because we know in systems that are running like for a long period, with the first failure is going to be a lot of reputation damaging, and it's a lot is going to impact negatively the way the team looks at AI and so on. So I think having the guardrails and having also a specific focus points in the context, for example, like your context might be geographical context, your context might be a specific activity type context to focus on. Like, not all AI we wanted to run, let's say, in day one in the regular day hours. Sometimes you want your AI to start by running within, let's say, outage windows, which is where we know that the impact is less. So it allows you to run the activity in real network, but it allows you to run it before it is high impact or high blast radius when it comes to the customer. And also you have to allow when to break the cycle. When do you actually go into a human being? We love to have the system running autonomous, but always like autopilot in flights is autopilot and is trusted by a pilot, but there still is a pilot in the flight, because if autopilot doesn't go, the risk of the decision making is high.
Fadi, maybe you could weigh in there, and I'd also reference in your talk, you mentioned A to A and MCP. So as these AI systems get more complex, as they move from narrow to more broad, how do you maintain consistent context?
Okay, so I want to take a step back to take a snapshot of where we were, where we are today, and where we're going to be. We started with the chat windows, question and answers. Model grew. Oh, we were so amazed. They're intelligent answers, and they kind of really accurate to the point, pointers for explaining things. And then there comes, okay, we grew their understanding. The size of the parameters increased. The context window they support now up to million and 2 million, 10 million tokens. So the context provides the supplementary information to make better decisions, better information association, and guides you better. But that is still a question and answer. This is where agentic transformation came into a picture, especially beginning of the, I would say, this year, and maybe the end of Q4 last year. We keep hearing agents. So cloud code agent, cloud work agent, codex. So what the agent brought up the ability of AI doing things for us, writing a code, rather than saying, hey, this piece of code is wrong and you should be doing this. Instead, go changes the module, go changes the code itself. It executes the CI/CD pipeline by itself. So agents started to do the stuff on behalf of us using their gigantic intelligence accumulated from the information that has been trained on. And then there comes, okay, there's no single agent. There could be multiple agents. Agents from, oh, open cloud, right? The open cloud transformation. So we are at the edge of agents talking to each other, multiple of them out there in the wild, delegating some tasks among themselves, based on their backend abilities, skill set, toolboxes, and still delivering complex workflows for us. This is where we are and where we're going to grow. Agentic orchestration, multi-tenant agents backed by different models at different network tiers. So when you look at this from the vision of the telecom infrastructure and needs, not every telecom operation needs a million context window. Most of the telecom operations are transactional. Okay, as long as you provide the necessary log, event, and metrics with the proper NAP documentation or proper accumulated, say, tickets resolved before, that's enough context size to address this, fixing the problem. It doesn't have to be million token. It cannot be million token because it's running at the edge. It has limited memory. It has limited compute capability, right? So what I'm hinting is agents will be from on-device to edge to regions to the core, backed by different model sizes, and yet they're talking to each other to delegate the task. This is where agent exchange concept coming into a picture we published on the GitHub repo and articles. I will highly suggest take a look at the agent exchange repo to understand the trust factor between agents. So agents cannot trust them each other blindly either. They have to have a trust factor, establishment, certification process, discovery process. This is where we are going. How agents discover each other, how agents build trust factor and trust scores, and how agents can delegate the tasks and perform the commerce. Hey, I'm asking you to do this. In return, I'm paying you this much money or this much of whatever credit you're using as a Unity.
Excellent. The information that Fatih is referencing is posted in the webinar chat if you'd like to take those links down. Raphael, I'd turn to you. You used the phrase in your presentation, adaptive learning. I think that's a clear process to me if we're talking about a narrow use case with very well-defined data sets that are relevant to the use case. How do you think about adaptive learning as AI tooling scales from subdomain to domain and then end to end?
Well, I think that there are definitely I think of SMEs really when I'm thinking of this adaptive learning. You know, there's still a lot of knowledge in the SMEs that needs to be brought into automation systems, right? And how these SMEs are going to interact with these systems, I think is an important piece of the whole AIOps or automation, right? Definitely this interaction with the SMEs has been made easy with the LLMs, right? And I think the key is how you put this knowledge back into the machine, right? How you put this knowledge into an optimal automation system that is able to deliver value, you know, and you turn basically your SMEs into an integral part of this automation system, right? So I think in the world of telecommunication, you know, the value that you know, folks that know about core RAN, you know, provisioning is super important, and you know, no automation system can come with all the possible scenarios, right? So when I say this adaptability will come both from SMEs and from systems detecting anomalies and suggesting changes that SMEs can now review fast and deploy into production in no time.
Excellent. Well, I appreciate you all going through those questions with me. We're at the end of the hour, but we'll stretch a little bit because I would just like to go around the table here and get some summary thoughts and really, you know, what's the one thing that our audience should take away from this discussion on AI ops? Ahmed, I'll start with you, please.
I think like start with the use cases that make sense to you, and also have the layer that you can have the transparency to understand what the machine is doing. As Fadi mentioned, we're now going to A2A and MCP, and the agents are gonna turn into something similar to how we viewed before neural networks. So it's gonna be a big black box where agents talk to each other, take decisions, and then you see the network changing. But having a layer of transparency and a layer of explainability is the way to build trust. We can always explain and comprehend what we can understand. So I think that this is where trust is built. So start there, build the framework, and make sure you can reuse that framework going forward for extra use cases. Do not build a specific framework for every use case.
Excellent. Then, Fatih, final thoughts from you. And I mean, your vision for distributed inference, I love it. How do we get from present state to that?
It is happening, right? So one thing I used to say, same as Ahmed, start with use case data. Then I realized it doesn't work like that, right? In the wild, people need to know what can I do with what, right? So say small language model, SLMs with 100 million, 200 million parameters that can fit in a consumer GPU. You can run really good models, say Qwen 3.5 or Kimi K2, whatever, the quantized version. Oh, I can address these use cases with this because now I know this is capable. If you were starting from the use case and you were saying, oh, the mapping of the use case to a resource could be not really ROI driven. It's going to be business driven, it's going to be operation driven, may not turn into reality. So this is coming to both ends, right? Use case, and what can you do with what? Small language models with VLLM at the edge, VLLM at the region, distributed VLLM with LLMD. You got to understand what's available for you today to use. We publish all these articles, open source GitHub repos. Be curious, like they say, right? Be curious, my friends. See what you have today and what's coming. The coming things are going to be more amazing by means of small capacity, less power consumption, easy to acquire, and reasonable priced, delivering a lot of autonomous jobs for you to save your time to do something bigger with your teams. But yet, human is not replaceable with AI. We are making our lives much efficient and effective using AI. This is one of the articles we published this week. It's called AI Provocateur. AI is not here to replace human. AI here to make us build some time to build greater things for in our spare time.
All right, excellent. And then, Raphael, I'd turn to you. Any summary thoughts you'd like to leave our audience with?
Yeah, I think just a couple of headlines, right? One is always think of the value proposition of your system, right? Or whatever you're building, right? I think value prop is probably the most important thing because people were questioning how much time, money you're spending on doing anything, right? And through the years, you will have to show this. So think about how your system is able to quantify those savings on a regular basis right now. And the second one is be ready to customize. You know, even the most perfect workflow will have to do different things in a different context, right? So customization will become important, you know, and how easy it is to, you know, customize your system and deploy or redeploy your models, you know, will become very important.
Excellent. Well, gentlemen, I want to thank you again for joining the discussion today and sharing your points of view, telling us about the work that you and your colleagues are doing around AIOps. It's a really compelling vision and a lot of hard work, but I'm glad that humans are going to remain in the loop for now, driving the decisions. So thank you again, and thank you for everyone that joined.
Thank
Thanks,
you.
John.